Hello, welcome to the Algebra of Complex Numbers. So, this is the chapter 3 of the book. So, in this chapter, we will study some basics about complex analysis, and it starts from the complex numbers. Since you know that there are two types of numbers, one are real numbers, which we have studied previously, and the other ones are complex numbers. So real numbers are the one which we have studied previously. For example, all natural numbers like 1, 2, 3, up to so on, they are also reals. All integers, for example, 0, plus minus 1, plus minus 2, plus minus 3, all they are also real numbers. All rational numbers, for example, plus minus 1 by 2 or 2 by 5, etc. All of these numbers are also reals. There are some irrational numbers like square root 2 with plus or minus, square root 5, etc. And there are some other numbers which are also real. They are special kind of real numbers called pi and e, and such kind of all numbers are called real numbers, which we have studied. These numbers are natural numbers. These numbers are called integers, denoted by z. Such kind of numbers are called rational numbers, and such kind of numbers are called irrational numbers. Okay, they all combine to form reals. Okay, if we make the picture of real numbers, it is like the bigger set for real numbers. All other numbers are inside this. Okay, for example, rational numbers are inside here, inside the real numbers, they are rationals. And integers are also inside of the reals, as well as they are inside the rational. Actually means integers are inside the rationals, and the natural numbers are inside of all numbers. So natural numbers are inside the set of integers, and set of integers are inside set of rational numbers, and they are inside the set of real numbers. So set of real numbers contain all of those numbers, all of these numbers. But there are still some numbers which are not real numbers. Okay, they are called complex numbers. So we start studying complex numbers like by solving some equations. So suppose we have some kind of equations like 2x minus 10 is equal to 0. If we solve this equation, what will you do? You will take this 10 here, you will get 2x is equal to 10. Then what you will do, you will divide both sides by 2 to get the value of x. It will be x is equal to 5. And this is real number because it is here inside the natural numbers. Okay, which is real. There is no problem. Okay, let us consider another example. For example, you have to solve this equation. If you solve this equation, first of all, you will take this number here. You will get 3x is equal to 2. Then you will divide both sides by 3. You will get x is equal to 2 by 3. And this number is again real number because 2 by 3 is here, right? All of the plus and minus numbers with fractions are rational, so all rationals are real. So it is again a real number. We have no problem. So let's do another example. If I solve x square minus 2 is equal to 0, first of all you will take this here. You will get x square is equal to 2. Then since you need to find the value of x, but here you have x square, so In order to kill this square, you will take square root on both sides. If you take square root on both sides, you will get x square root is equal to square root of 2 with plus and minus. Whenever we take square root, we write plus and minus. So the value of x here is plus and minus square root 2, which is also real number because it lies here, and they are all irrational numbers. They are called irrational, but they are reals. Okay, so this is also real. So we have no problem with solving these kind of equations. Whenever we solve these kind of equations, we get real number. As long as we are getting real number, we have no problem. But the story gets changed when we consider this kind of example. This is the interesting part of the story. Okay, what will you do? First of all, you will take this 1 to the other side. You will get x square is equal to minus 1. Since you need x, but this is x square, right? We don't need square, so we will kill this square by taking square root. How will I kill the square? So I will take square root on both sides. Here and here I will have plus and minus. I have to take square root of minus 1. I will get square root of minus 1. But this number is no longer a real number because this kind of numbers are not real. Okay, because there is something negative inside the square root. For real numbers, we have everything positive inside the square root. Okay, so if everything is positive inside the square root, then the numbers are real. If we see something negative, it does not belong to the set of real numbers because it has no real meaning. Why? Because if you think a square whose length is x and whose height is also x, if I ask you to find the area of this square, it will be x square. This multiply by this. Okay, so this is okay in the real world. Okay, so I told you that this cannot be a real number. This is an imaginary number. Because it is x square is equal to, because this number is obtained from this equation. If you look at this equation means x square is equal to minus 1. What does that mean? X square is equal to minus 1 means we have a square whose one length is x and whose area is minus 1. Okay, let's look. For example, you have a square whose one side is x, the other side is also x. If I ask you to find its area, it means you will multiply these two things, you will get x squared. Okay, so what will happen if I change this square, if I change the sides by 1? What will happen? Then the area, of course, it is 1 square, which is 1. That makes sense, which is positive. So area is the thing which is always positive. I mean, because you will take the square of a thing. Anything square is always positive. Or max or minimum, it must be 0. Or minimum it can be 0, but it is always positive. So in the real world, as long as in the real world we are in the real world, there is no shape whose area is negative. But if we get some shape whose area is negative like this, then that shape is not in the real world. We will say that it is in the complex plane, somewhere in the imaginary space, or in the space where we can only imagine, right? So we will say if we have a square whose area is negative, for example, if I say that its area is -1, what will I get? What does that mean? That means if this is the length, for example, I, this is also I, then area must be I square. Since I have assumed that the area is -1, so I will call this special number whose square is -1, I will call this iota, a complex number iota. Okay? So this number is not a real number, because if it was a real number, its square must be greater than 0. But since its square is negative, which is not greater than 0, that means this number iota is no longer a real number. It must be some other number which is not real. We call these kind of numbers as complex numbers. So here is the definition. So first of all, remember, I have defined iota as square root -1. This number is called iota, whose square root is -1, or I will say iota square is 1. A number whose square is, not 1, -1. Because if it is 1, then there is no problem. It will be positive, and the positive area is always in the real world. But we are in the complex or imaginary world. So iota is a special kind of number which leads us to define some numbers called the complex numbers. Okay? So now we will define the complex numbers. Any number of the form a plus b iota. Here, these spaces are for real numbers. Any combination of this form, for example, a plus b iota, is called a complex number. Here, a and b are real numbers. They are real. Moreover, the real part of the complex number is this one, which is without iota, and the imaginary part, which is more interesting, is a number with iota, right? The coefficient of iota is called the imaginary part. So any complex number has two parts, the real part and the imaginary parts. Here we have examples. For example, 2 plus 3 iota is a complex number. -1 plus iota is also a complex number. 0, just 0. We can write 0 as 0 plus 0 iota, which is again 0. So this is also a complex number, right? You can call 2 iota. 2 iota can also be written as 0 plus 2 iota. So all of these numbers are the combination of this type, okay? So any combination of this type is called a complex number. So these are all complex numbers. So for example, in this thing, the real part is 2 and imaginary part is 3, okay? And in this number, real part is -1 and imaginary part is 1, because this is -1, and here with iota, if there is no coefficient, we will consider that's 1, okay? Okay, for this number, the real part is 0 and the imaginary part is also 0. And for this number, the real part is 0 and the imaginary part is 2. Make sense? Okay. Next we have a definition. If in the combination a plus b iota, if a is 0 and b is not 0, then the number is called pure complex, okay, or imaginary number. Okay, so if the first part is 0 and this is not 0, then the number is called pure complex. For example, if you have 2 iota, okay, you can check it is 0 plus 2 iota. The first part is 0 and the other part is not 0. Another example, iota. So in this example, you can write 0 plus 1 times iota, right? So this is 0, this is not 0. 2 by 5 iota. This is also the same type. So these numbers are called pure imaginary, pure complex. They are called pure complex numbers. Okay, we have another definition. Based on this definition, in this definition, we considered that if a is 0, b is not 0, then the number is called pure complex. What will happen if the other way around is? For example, if this is 0 and this is not 0, then the number is called real, okay? So I have written the definition. If in this part, this is 0 and this is not 0, then the number is called real number, okay? And of course, every real number is also a complex numbers, but every complex number is not a real number. Here are examples of this definition. For example, 2 is a real number. You know 2 is a real number? You know. But I can write 2 as 2 plus 0 iota. And by this definition, you can check b is 0 and this thing is not 0, right? So by this definition, it is also a real. Okay, if I write minus 1, it is again minus 1 plus 0 iota. It is also a real number. You know minus 1 is a real number? Okay, 5 by 2. It is also a real because I can write 5 by 2 plus 0 iota. So all of these numbers, the imaginary part is 0. If the imaginary part is 0, means there is no imaginary part. That means you have only real part. So if you have only real part, that means the number is called real number. It's very simple, okay?